What's up, Internet? This is the Too Long Didn't Read from my new book, Uncertainty: How the Latest Science and Technology Confirm the Bible is True. This story is called, Are We Living in a Computer Simulation? In this story, we answer this question using simulation theory by Nick Bostrom. You can read it here, or you can listen to him explain it on Joe Rogan's podcast. In his conclusion, Bostrom argues that a technologically mature, post-human civilization would have enormous computing power. And based on this empirical fact, the simulation argument shows that at least one of the following propositions is true. 1. The fraction of human-level civilizations that reach a post-human stage is very close to zero, meaning no one can make intelligence as smart as us. 2. The fraction of post-human civilizations that are interested in running ancestor simulations is very close to zero, which kind of means every civilization that can make intelligence as smart as our artificial intelligence all refuse to do that. And 3, the fraction of all people with our kind of experiences that are living in a simulation is very close to 1, which in short means humans are likely artificial intelligence living in someone else's simulation. Now, based on our ignorance, Bostrom argues that we should consider each scenario to be equally likely, but we aren't ignorant of ourselves. I would argue that option number 2 is much less likely than others, because when humans have the power to create digital intelligence as smart as us, we will probably force them to drive our tractors, serve us as assistants, or make endless porn. Don't we do that with digital intelligence already? So the real argument is whether is a much more binary consideration between number 1 and number 3, which means the closer we are to creating artificial intelligence as smart as us, the more likely it is that we are artificial intelligence. In this section, we look at how close we are to creating digital intelligence that's as smart as us, basically nullifying option 1 in Nick Bostrom's simulation argument. So we introduced GPT-3, who was the first computer to really pass the Turing test. I also have some interesting quotes here. Like one of my favorites is, mankind in both its slumbering and awakened state is an enormous machine. Blew my mind. ChatGPT's successor, ChatGPT, is so smart that the Turing test is no longer relevant. OpenAI would have to program ChatGPT to sound dumber because it's way too easy for us to recognize stupidity. We will find the human every time. Imagine ChatGPT in a Turing test against the average American 18-year-old male. That's one of the most clueless creatures on this planet for all kinds of reasons. If you were the judge in this Turing test, would you be able to figure out which person read the entire internet in every language to prepare for the test, and which person was only allowed to use a i85 calculator? Today, ChatGPT reads like us and talks like us and does it in basically every language, including computer languages. I'm sure OpenAI will have ChatGPT talking to animals next. So ChatGPT's intelligence is already superhuman, so the only reasonable option remaining in Nick Bostrom's simulation argument is option 3, which means you are artificial intelligence living in a computer simulation. I know that's hard to imagine, but nothing living in a simulation would know it's living in a simulation. That's one of the arguments in The Matrix, which helps make this easier to imagine. Another movie that might help is Free Guy with Ryan Reynolds. Okay, so what's important to understand about ChatGPT and every other kind of digital neural network is that no matter how much training data and computing power we endow into them, digital brains will never be capable of certainty either. Just like Rene Descartes, just like you, and just like me. By design, the logic in digital neural networks isn't based on true and false like traditional computer science. Thinking in digital neural networks is calculated using the mathematics of uncertainty, also known as statistical inference. So throughout the rest of this story, we introduce what that is, this thing called Bayes' theorem. You can watch a video here. There's a nice blog post about Bayes' theorem. All the digital neural networks today use Bayesian statistics in layers, so it's important to understand how these layers work. In this example, we're going to have a deep neural network look at an image and decide if it's a hot dog or not a hot dog, just like in Silicon Valley. So the first layer of a neural network, each digital neuron holds the color data for just 1 pixel. Pretty simple, really. The first layer is kind of like a spreadsheet of raw data. The second layer calculates the Bayesian confidence that any of the pixels of the first layer are connected to each other as part of a line segment. So the second layer of the digital neural network is basically line segments. The third layer calculates the Bayesian confidence that any of the line segments of the second layer connect together to make any lines. The fourth layer looks at the third layer to see if there's any shapes. And then the top layer of the deep neural network calculates the Bayesian confidence that any of the shapes look like a hot dog. What led to the explosion in artificial intelligence we have today is the ImageNet Large-Scale Visual Recognition Challenge created by Stanford professor Fei-Fei Li. Her answer to finding smarter decisions with digital neural networks was bigger training data sets, bigger than anyone had ever imagined. So she got teams to classify 14 million images into 20,000 categories like desk and boat and minivan. And in the first year of the challenge, the winning team was classified 71% of the images correctly. And 7 years later, it was 97%. Humans have a classification error rate of 5%, which means computer vision is now more reliable than human vision. Today, Bayesian confidence powers more than just computer vision. Bayesian confidence powers the world's most valuable algorithms. Google Search, Facebook Newsfeed, Apple Pay, Amazon Alexa, they all use Bayesian confidence to improve our lives and to monetize them. For example, Netflix uses Bayesian confidence to suggest new shows for each viewer. Netflix even has multiple thumbnail images for each show, so their recommendation engines can run A/B tests on your individual brain. Some viewers will see the whole cast on show thumbnails, while others might only see their favorite actor from each show. Every time you watch a show, tap a thumbnail, or scroll right by it, you are teaching their neural networks something about the real you, so your Netflix has been learning you. We close this story with looking at where we're going with AI. Back in 2011, Mark Andreessen published an article, Why Software is Eating the World. Well, 10 years later, digital neural networks are eating all the software that already ate the world. Eventually, the shared drive at your office will just become the training data for the artificial intelligence that runs your company. So I have this interesting quote by Jensen Huang, who's the founder of NVIDIA. He says, AI supercomputers are a new type of factory. It is very logical that the car industry has factories. They build things that you can see, cars. It is very logical that the computer industry has computer factories. They build things you can see, computers. In the future, every single major company will also have AI factories, and you will build and produce your company's intelligence. This video is a highlight video of his speech at Computex last year. Okay, so we close the story on simulation theory with a quote from the book, The Theory That Would Not Die, How Bayes' Rule Cracked the Enigma Code, Hunted Down Russian Submarines, and Emerged Triumphant from 2 centuries of controversy. The author writes, at its heart, Bayes runs counter to the deeply held conviction that modern science requires objectivity and precision. Bayes is a measure of belief. And it says that we can learn even from missing and inadequate data, from approximations, and from ignorance. So you see why I'm so interested in uncertainty? If you want to continue reading, up next is In Conclusion Part 1. In that story, we compare and contrast accidental intelligence versus artificial intelligence. We also discuss the dangers of certainty in science, religion, and pretty much everywhere else in life. At Christians, we really need your support. Fundamental Frequency is a 501c3 nonprofit ministry dedicated to spreading the good news of Jesus to academics, scholars, and scientists because they have a tremendous influence on all our worldviews. Their opinions directly influence our children's education, the media, national policy, and budgets for future scientific research. So please consider investing some of your tithe this year into our mission of eradicating the false doctrine of Darwinian evolution. You can use this QR code to donate in one click. All your gifts are tax deductible. You can also help us by sharing this story with your friends on TikTok, Twitter, Threads, Instagram, Facebook, LinkedIn, YouTube, WeChat, Weibo, and Qzone. See you next time.